Hi guys, how are you? I hope you and your family are doing well. Today I'm going to talk a little bit about the dot product. So last time I introduced the notion of vectors and I said there are a couple of operations you can do on vectors. So the first operation we can do on vectors, we said that will be addition and subtraction. Okay. Now the important thing here is that when you add or subtract two vectors, the answer would be a vector. Okay, the addition of two vectors is a vector. When you subtract two vectors, you get a vector, right? So for example here, let's say vector u is the vector 1 2 3, and vector v is, let's say, 2 3 and -1. So then u plus v, that will be equal to, so 1 plus 2, comma, that's the first coordinate, and then 2 plus 3, comma, and then we have 3 plus -1, so 3 plus -1. So that will be the third coordinate, right? So that will be equal to 3, 5, and then 2. Okay, so u plus v is equal to the vector 3, 5, 5, 2. So as you see, the answer is a vector. Okay. Now, second operation would be the scalar multiplication. So actually, we can multiply a vector by a number. So, for example, let's say the vector u is equal to 1, 2, -1. So if you want to do, for example, -3 times u, so that would be -3. The number of -3 times the vector 1 to -1, so that will be equal to, and now what you do, you multiply each component by -3. So this is like -3 times 1, and then -3 times 2, and then -3 times -1, right? So then the answer would be -3, -6, and +3. Okay, so that's the -3 times u. So what I did is I multiplied the vector u by the number -3. But the answer, of course, is a vector. Okay. So again, these two operations, so addition, subtraction, when you add or subtract two vectors, you get a vector. And when you multiply a vector by a number, you get a vector. Okay. Now, the third operation we're going to do, it's actually the dot product. So the dot product of two vectors, first notation. So it's called dot product because, in the notation we use a dot. So that would be like u dot, okay, u dot v. Okay. So this is the dot product of u with v. Or u dot v. Okay. Now the formula for the dot product. So we actually have two formulas. So the first formula, formula 1. So let's say you have vector u equal to u1 u1, u2, u3, okay, and vector v. So let's say here v is equal to, so it's given, let's say v is given by v1, v2, v3, okay. Then the formula is the following. So u dot v, the dot product, it's actually u1 times v1 plus u2 times v2 plus u3 times v3. Okay. Now, the important thing here is that, the first remark is that the answer, so what you get as a result, it's actually a number. So here this is a number. Okay, so u dot v, the dot product of two vectors, it doesn't give you a vector, it gives you actually a number. So for example, let's say u is equal to 1, 2, 3, v is equal to -1, -3, and 4. So then u dot v is actually equal to the number 1 times -1 plus, so u1 times v1, right? So this number here times this one here, so 1 times -1 plus 2 times -3, right? So plus 2 times -3 plus, and then 3 times 4. So then plus 3 times 4. So u dot v is equal -1 plus -6 plus 12. So that's -7 plus 12. So that's +5. So u dot v equal to +5. Okay, so it's a number. You see, so the answer is a number. It's not a vector. Again, it's a number. Okay, now what's the geometric, let's say, geometric interpretation of this number? Well, you can see the geometric interpretation of this number if you know the second formula, this second formula of the dot product. So formula number 2. Actually, u dot v is also equal to the length of u times the length of v, or the magnitude of v, okay, times cosine of theta. So what's theta? Theta is actually the angle between the vectors u and v. So let's say this is u, okay, and let's say this is the vector v. So theta is the angle from the vector u, between the vector u and the vector v. Here's theta. Just one remark here, theta must be in the interval 0 pi, okay. So, and again, here, this is, remember guys, this is the length of the vector u. This is here, this is the length of the vector v. Okay. And in particular, guys, so you can see here from this formula that cosine, so here corollary, so you see that cosine of the angle theta, so the cosine of the angle between the two vectors u and v is actually equal to, so you can do u dot v over the length of u times the length of v, right? So all you have to do here is, you see, so here in this formula here, all you have to do is, you can just divide by, you divide both sides by the length of u and the length of v. So then this cosine of theta here would be equal to u dot v divided by this length of u times the length of v. So, for example, let's say, here's an example. Let's say we have these two vectors, u is equal to 2, 1, -1, and v is the vector 1, 3, and 5. Okay, and the question is to find, when I find the angle between U and V. Okay. Well, to find the angle, well, you can use the two formulas. So for step one, so what you do in step one, first let's compute U dot V. Okay. Well, U dot V, we said if you use the formula 1, so U dot V, so here if I use formula number 1, remember formula 1 we said U dot V, that will be U1 V1 plus U2 V2 plus U3 V3, right? That's the formula, our formula number 1. So that will be equal to, so what's U1? U1 is 2. V1 is 1. So that will be 2 times 1 plus, and then U2 times V2. So U2 is 1 here, and V2 is 3. So 1 times 3 plus U3 times V3, right? So U3 is negative 1, and V3 is 5. Okay. So that'll be equal to, so 2 plus 3, that's 3, minus 5, that's 0. So U dot V is actually equal to 0, right? So here I use the formula number 1. Now, by the formula number 2, so here's the step 2. Now I'm going to use the formula number 2. So step 2, well, if you use the formula 2, remember formula 2 says U dot V is equal to the length of U times the length of V times the cosine of the angle between the two vectors, right? So I know what's U dot V. We know that U dot V is actually equal, I just computed in the first step, so step 1, this is actually equal to 0, right? Now, what's the length of the vector U? Okay, so let's compute the length of the vector U. So length of U. Remember, guys, U was the vector 2, 1, negative 1, right? So remember the square root of, so the length of the vector U would be the square root of 2 square plus 1 square plus negative 1 square. Right? So that would be equal to square root of 6. Now, vector V. Vector V, so the length of the vector V is equal to, so vector V, remember guys, vector V was equal to, 1, 3, 5, right? So the length of the vector V would be square root of 1 square plus 3 square plus 5 square. So that's square root of 1, so 1 plus 9, that's 10. 10 plus 25, that's 35. So that's square root of 35. Okay, so we know, so here if you use the formula number 2, so we said that's cosine of theta would be U dot V over the length of U times the length of V. So that's equal to, so step 1 we said U dot V is actually 0, right? So this is 0 over length of U is square root of 6 times length of V is square root of 35, right? So that's 0 over square root of, so 6 times 35, that will be 210. Okay, so that's equal, of course, to 0. So cosine of theta is equal to 0. Okay, and again, so for which angle, so theta would be arccosine of 0. So for which angle does a cosine is equal to 0? Well, arccosine of 0, that's actually pi over 2. That's 90 degrees, right? Remember, guys, cosine of 90 degrees is 0. Okay, so theta is equal to pi over 2, 90 degrees. So that's the angle between U and V, and actually, because, well, so it's 90 degrees, so that's a right angle, right? So then U is perpendicular to V. So here's vector U, here is my vector V, and actually U is perpendicular to V. So U is perpendicular to V. Or if we can use this notation here for perpendicular. So this is for perpendicular. Okay. So that's actually a general fact. So if U dot V, so fact, if U dot V is 0, if U dot V is 0, okay, then actually it means then that U is perpendicular to V. Okay, so the two vectors are perpendicular. So here's U, V. So whenever if you wanna check that two vectors are perpendicular, all you have to do is to compute the dot product. So if the dot product is the number 0, okay, then the two vectors actually are perpendicular. Okay. Now that's fact number 1. Another interesting fact is that if you do U dot U, okay, so what's U dot U? Well, U dot U would be, if you use the formula, so we have the length of U times the length of U times the cosine of the angle between U and U, right? So this is vector U, and here is again vector U. So what's the angle between U and itself? Well, it's just 0. So that's cosine of 0, and of course cosine of 0 is 1. So then U dot U is actually equal to the length of U squared. Okay. And for example, corollary, if for example U dot U is equal to 1, it means actually the length of U is equal to 1. So U is of unit length. Okay, so for example, let's say the vector U is equal to 2 over square root of 6, 1 over square root of 6, 1 over square root of 6. Okay, so if you do U dot U, so that's 2 over square root of 6 times 2 over square root of 6 plus 1 over square root of 6 times 1 over square root of 6, right, plus 1 over square root of 6 times 1 over square root of 6, right? So that's u1 times u1 plus u2 times u2 plus u3 times u3, right? It's the same vector. So that will be equal to, so u dot u is equal to 4 over 6 plus 1 over 6 plus 1 over 6. So actually that's 6 over 6 is equal to 1. Okay, so u dot u is equal to 1. So then that means that u is of unit length. So then the length of u is equal to 1. Okay, so u is a unit vector. Okay. Okay, probably last thing we can we can talk about is the projection of a vector v onto vector u. So what's this projection? What's the projection of v onto u? Well, so let's say this is my vector u, and here let's say this is the vector v. Okay, so both they have the same initial point, right? Both they start at this point here. They have the same initial point. So what's the projection of v onto u? So what you do is you take the terminal point of v here, take this terminal point, and you draw like a perpendicular line to the vector u. Okay, here. So here you have a right angle. Okay, so this vector here. Okay, sorry. So this is here's the u, and okay, so you draw this perpendicular line to the vector u, which passes through the terminal point of v here. Okay, so we have this right angle here. Okay, so then the projection of v onto u would be this vector here, this one here. Okay, probably I should use the this black vector, that's what we call the projection of v onto u. Okay, so this is the notation, so projection of v onto u. Okay, so that's the projection of v onto the vector u. Okay, it's given by this vector here. So so now the question, how do we compute? So let's try to find or let's try to compute this projection of v onto u. So this projection is a vector, right? This black vector here. So what would be the formula for this projection vector? So here's the formula for the projection of v onto u. So the formula is the following. So projection of v onto u is equal to u dot v, that's a number, over the length of u square, that's another number, so this is just a number, times the vector u. So times times the vector u. Okay, so then the whole thing, of course, this is, so here, this thing here, this is a number, of course, because the dot product is a number. The length of u square, it's another number, right? And then, of course, when you multiply a number by a vector, right, you get a vector, right? So for example, let's do an example so you can see what I'm talking about here. So let's say here's the vector u. So example, let's say u is equal to the vector 1, 1, 2, and v the vector -2, 1, 1. Okay, so let's say here's the vector u, here this is the vector v, and I want to find the projection of v onto u, so that will be this vector here, this one here. So this is the projection of v onto u. Okay, so let's compute this projection. So projection of v onto u, so we said it's equal to u dot v over the length of u square times the vector u. Okay, so first we need to compute, so in this formula here, so first we need to compute u dot v, then the length of u square, and then multiply by the vector u, right? So first, what's u dot v? So it's gonna be 1 times -2, so 1 times -2 plus 1 times 1 plus 2 times 1. So u dot v is equal to, so -2 plus 1, that's -1, plus 2, that will be +1. So u dot v is equal to the number 1. Now, what's the length of u square? Well, the length of u, right, square. So the length of u, remember guys, that's the square root of u1 square plus u2 square plus u3 square, and then because of the square here, so we need to take a square here. So that's the length of u square. So of course the square root and the square, they cancel out, right? The square root and the square cancel out, so it's just equal to u1 square plus u2 square plus u3 square. So that's equal to, so u1 is 1, so 1 square, plus u2 is 1, so plus 1 square. So again, this is u1, this is u2, and this is u3, right? And then plus u3 square, so plus 2 square. So that's 1 plus 1 plus 4, so that's equal to 6. So the length of u square is equal to 6. So we are almost done now. So what we are saying is that, so projection of v onto u, so it's, we said u dot v over the length of u square times the vector u. So projection of v onto u, so u dot v, we said it's equal to 1, so it's 1 over the length of u square, we said it's 6, so over 6 times the vector u. The vector u is 1, 1, 2, so times the vector 1, 1, 2. So then projection of v onto u would be equal to, so we multiply 1 over 6 times 1, and then 1 over 6 times 1, and then 1 over 6 times 2. So then the answer, projection of v onto u, would be 1 over 6, 1 over 6, and then 2 over 6, okay, which is, of course, so 1 over 6, 1 over 6, and then 1/3. Okay. So that will be the projection of V onto U. Okay, guys, anyway, I'm going to stop here. You can find more details in the lecture notes and the extra video. Thank you. See you next time.